This is the second video for the 6-1E lesson. We're going to simplify show our work, and I'm going to go through these using a technique I like to use, but again, it does not need to be this technique. And a question you should ask yourself is, why did I pick the numbers I chose to break this up? Part of it is just guess and test in a calculator, picking a perfect square that goes into this, or starting with two, and also doing having more practice with this. You'll know which is maybe best as far as avenues for breaking these numbers up. So for example, 1800, 1800, 2 probably goes into this a lot. So I might start with something else, like randomly just pick a perfect square and see if it goes in. Or it ends in two zeros. So maybe I'm tempted to use 100 times 18. I'm going to start to craft my answer here. Rather than break this up into the two tens or the 2 5 2 5 that go and form this, I'm just going to circle it because I know it's a perfect square and the square root of it is 10. 18 has some pairs in it or perfect squares. So 18 is 9 times 2. And I found a perfect square, or if I'm not convinced, I keep going. And there is my pair of threes. Again, I could have just circled the 9 here. And I put one representative here, and there is a 2 left over. And so what is considered my simplified answer, or answer in simplest radical form, is 30 root 2. And actually looking at this, I now can see that if there's a 30 here, it probably was a 900 in a previous life, because the square root of 900 is 30. So, and when I'm done with the problem, I might actually see a better way or more efficient way to do some of these. But again, you just kind of pick something and try it. And with more practice, you might see which works best for you. 135. If I can't think of something, maybe I just start with 5 and say, you know what, I'm just going to go with this. And in my calculator, I just break this up, or by hand, 5 times 27. But I'm not just typing in the square root of 135 in a calculator. I'm just using a calculator to help me maybe factor tree till I feel like I'm at a good spot. Bring down this 5 so I don't forget it. And this is 9 times 3. And I'm going to stop here because I think I found all my pairs or perfect squares. So 9, square root of 9 is 3. So it's a pair of threes. And the 5 and the 3 are not pairs. They don't have any common factors other than 1. So 3 root 15. Next one, we're going to start to look at variables. We have x cubed. So it says explain your process, but I'm just going to show work for this, and we're going to kind of think about this a couple of ways. The first option would be is that we just expand this out, sort of like we talked about with our two methods in the first video. And we see a pair here. So out comes one representative, and then this one is left inside. And that is our answer. Rather than do it in factor tree form, I did sort of my factor tree as this expanded form. And like in module 5, as you can see, we're going to start to look at exponent stuff. We're going to maybe try to figure out some shortcuts with exponents. And you can see that we're kind of using the idea of exponent properties, that 1 plus 1 plus 1 is 3. So number 6, same idea. So we'll start with kind of the longest way, maybe the worst way to do this until we kind of figure out the trick, which is we expand this out. But it is worthwhile to do this a couple times to see how this might work. There's a pair, there's a pair, there's a pair. So out comes 1 for that pair, another one, and that one is stuck inside with no friends inside the radical. And y times y times y is y cubed. So then we start to think, is there another way to do this? And a good way to do this would be, first of all, this is an issue, unlike this one, in that it has an odd exponent. And so a good way to kind of hack this problem is that you bring this down by 1 from 7 to 6, which is an even exponent. And we know this is going to be stuck in our answer. And if this is even, then it is a perfect square because y cubed times y cubed is y to the 6th. So there is our pair. You can kind of see also how to maybe get there without having to do this, how to break it apart. Why did I break it apart into these two? Because I didn't want to factor tree y to the 6th to y times y times y times y times y times y. So I did y cubed and y cubed. It seemed the most efficient. And then square root of y. Not to mention in the 6-1A lesson, they had you practice square roots with variables that had probably in most cases even exponents. Number 7, 512 x to the 4th square rooted. So this is a perfect square. I'm just going to start to set up my answer. So it out comes an x squared. And so that one, when it's even, it's easier. And if you need to show this, you can. All right, so that's taken care of. There is no more of that under the square root. And then 512, I'm just going to just pick something in my calculator and say test 9, it's a perfect square. Test 25, that's a perfect square. Test 100, or cut it in half and maybe stumble on 256, which is a perfect square, which is a pair of 16s. I definitely don't want to prime factor this because that's just a lot of 2s. So out comes 116, and don't forget this 2, and there is a 2 left inside. So we have 16 x to the second root 2. And we're also starting to notice the way to format the answer, that it should be the portion that came out that was rational and the irrational part at the end. Also, maybe leaving some breathing room here in that at some point we might be doing a cube root and we might need to put another number here. So this 2, we don't want it to kind of creep into some weird spot in our final answer.